Okay guys, I'm back. This is part 3 of the Lap 1-3 review. I hope these videos are helpful, and again, we will flip the classroom moving into Lap 1-4, and again, I have not had any time at all to shoot any videos, so definitely make sure one more time that you are constantly staying on top of rewriting the notes in the PowerPoints, even for the PowerPoints that are not being filled in because we run out of time because of questions. Again, take the initiative on yourself to come in and see me, and then let me either finish the notes with you one-on-one, or we have to just move quicker in the class. So I need you to understand that as a group, all right, for us to be able to get through the material. And of course I do want to answer questions, but I think if I flip the classroom and shoot the videos ahead of time, I do feel like it will work out better. That way when you come to class, we're just doing more practice and maybe doing some homeworks together, and then we'll see how it goes in 1-4. All right, so again, that's my little spill on it. But if there's things that are not filled in, come in and see me. You also have other resources, which means look it up on YouTube, and then of course make sure you stay on top of doing the homework and ask me specific homework questions that were challenging. All right, so now let's move into another thing that's in Lap 1-3, which is graphing inequalities. Now I'm going to write a note here that, again, I gotta do a screenshot. I know that on the concept check that Block 5 took today, and even the one that Block 3 had, everything is fair game, all right? But one thing I've already seen from the test is they did have another one that was over an absolute value inequality, because as you can see, you have lines with inequalities. They can also ask you an absolute value with a line. But what I will do to be fair, I'll just change so that it's 2 lines, but I'm just saying the other groups are getting anything. They're getting lines with inequalities, and they're also getting absolute value. You have to stay on top of that for the midterm. So you got to go back over that and have that fresh in your mind. But again, we'll get to that. It'll come back up later. So let's just be fair, and I'm going to make sure to, on the concept check, throw out the one that had to do with the inequalities with the absolute value. Those of you that got it, great, you're on the right track. Those of you that didn't get it, don't cry about it, okay? Make sure you stay on top of what that was about and go from there, all right? So let's get into this one. I'm going to change both of these into slope-intercept. So I have here 3y, oops, for some reason it went away. 3y, why can't I write? There we go. 3y greater than, and I got negative x plus 3. Again, you can sit back and think of the inequality for the moment like you can have an equal sign, but you got a shade, so just leave it there. So I'm going to divide by 3 to each term, and I get y is greater than. There's nothing to flip because there's a positive 3 that you're dividing by. If it would have been a negative 3, then I would change the direction of the inequality. All right, so again, I have negative 1/3 x, and then I have 3 divided by 3. This is a plus 1. All right. For the next one, same thing, 3y, but this one has a less than. I'm going to subtract the negative x over to the right side of the inequality, and there's a minus 9. Dividing by 3, here, here, and here will make this become y less than negative 1/3 x, and then minus 3. All right, so one thing I notice is my m's are the same, so they're parallel, and the y-intercepts are different. So let's see what happens, all right? So in this case, and did you see how before I even start to graph, that's where the critical thinking and your mindset comes from? Because before we talked about classifying systems, right? We said, hey, if my M1 is equal to my M2, I hope that you're listening, please. If they're equal, we know they're parallel. If they're parallel, they won't intersect. So once you start graphing, you better not get intersecting lines. Now our B1 is different from our B2, okay, and that's fine. But the whole point is that, hey, we're parallel, so you shouldn't get a point of intersection. All right, so let's go. So I'm going to go back and I'm going to do colors, all right? So this one I'm going to do in red, and the bottom one I'm going to do in like another color. I'm just going to say like blue. Okay, so back to red. Okay, so when I look at my y-intercept, which is right there, it's at 1. So 0, 1 is right here. The address, which I'm looking right here for my m, is down 1, 3 to the right, down 1, 3 to the right. So go back to the y-intercept. I have people who, I don't know, they make a point, and then from that point, they're doing their stuff. You have to go to the y-intercept. So let's go down 1, and 3 to the right. So 1, 2, 3. I'm going to put a dot right here. I'm going to go back to the y-intercept, and guess what? I'm going to do the opposite. I'm going to go up 1 and 3 to the left. Up 1. You could have went back to this point and did it again if you want, but I like to go back to the y-intercept. I'm going to go up 1 and then 1, 2, 3. Be really neat with your graphing if you want credit for it. All right, so now I know that because my inequality does not have a line under the inequality symbol, it's dashed. So very carefully through here, and I would have some kind of straight edge or ruler, and I think this looks really bad the way I drew it. Let me see if I can fix this. I just need to put my little dashes like that. Okay, so that's dashed. I really should show more dashed than like little blotches, all right? But again, I read from the y perspective, so when I read this right here, I'm saying y is greater. I want all values that are greater than my line. So I'm doing everything greater. That's where all my y values are positive and greater. All right, now I'm going to switch to blue. And for this one, I know the y-intercept, I know the y-intercept is at -3. So right here at -3, there's my y-intercept. My address is the same. Down 1, 3 to the right, down 1, 3 to the right. So I'm going to go down 1, 1, 2, 3 to the right, end up right here. And again, I like to come back to the y-intercept so I get a point over to the other side. But if you want to continue from this point and again do the address again, go down 1 and then over 1, 2, 3. You're more than welcome to do that. Okay. Again, there's no line under the inequality symbol. So again, this is a dashed line. Like that. You can go like that. Okay. And again, I'm reading from the y perspective. So when I read from left to right, I'm saying y is less than. And that's it. They have no points of intersection. They have no common solution, and they shouldn't, because they don't intersect. They don't carry anything. Okay. So that would be how we graph that. And all it's showing, I think, on the answer key, I'm just looking at someone's work, and I think they just chose a value. What did they do? Oh, they're showing how to do it by standard form, like how to do it with the x-intercept and y-intercept. But again, we just did slope-intercept, and then we used the address. All right, so let's go to number 15. And I'm going to have to do another screenshot. All right, so for this one, I want to kind of show different methods just to be safe so that you guys don't get to, that's fine. I'm going to just stick with what we were doing, but I did want to show how could I do it just leaving it in standard form, but I won't. All right, so for this one, everybody stick with what we know. Greater than or equal to -x plus 4. Again, now here's the situation with this one. If I divide by -1 to every single term, if I divide by a negative or multiply by a negative to isolate, you know, my x or whatever I'm solving for, I'm saying you flip the direction. So this becomes y, instead of it being greater than or equal to, it becomes less than or equal to, and we have a positive x minus 4 for the top one. For this bottom one, we had 4y greater than or equal to negative 2x plus 10. I just moved the x term over. Now I'm dividing by 4 to every term, and this becomes y is greater than or equal to negative 1/2 x, and then I just have this 10/4. Again, do not freak out with fractions. So I would tell myself, hey, let me go ahead and change this. Again, I like to tell my younger students TBO, top in, bottom out. So 4 divides into 10 2 times for 8. 10 minus 8 is 2. So that would become 2/4, which reduces to 1/2. Okay, so 10 over 4 is the same as 2 and 1/2. Okay, so 2.5. All right, so now I'm going to graph, and I'm just going to do this one in blue. The top one, bottom one I'm going to do in green. Put a G. Let's go back to blue. Okay, I hope I'm in blue. Now, the issue I'm having with this one is I cut my screen off, so I don't think I'm going to make it. Give me a second. Close out of this one. I cut the screen off, so I'm going to move this up for a second right here. And then I'm going to screenshot this again. Sorry about that. All right, so for this one, I believe we had, let me try to do it from memory. I had a y, instead of it being greater than or equal to, it was less than or equal to. And then I had negative x divided by, I had an x minus 4. Right. And the green one, let me change colors. This guy was y greater than or equal to negative 1/2 x, I think. And then I had the 2.5, but it was a positive 2.5. Yeah. Again, 1 second. It was 10/4, just so y'all know. And again, that's who I was calling 2.5. That's what this is. All right, I'm back. All right, so I'm going to graph the bottom one in green. So 2.5 positive is right here. This is my 3. So I'm just going to put a dot right in the middle between here. And again, I said be really careful. In this case, our m is -1/2. So our address is we're going down 1 and we're going to the right 2. So very carefully, I said, hey, I'm already at 2.5. I'm going down 1. So take away 1. And that's 1.5. Okay. So I got that. So I went down 1. I'm going to be at 1.5, which is right here. And then I want to go 2 to the right. So right here, go over 1, 2. And I'll put a dot. And erase away the little parts that are distracting. Okay. Then I also can do the opposite. I can go back to my y-intercept, and I could go up 1 and 2 to the left. So if I was at 2.5, and I went up 1, see what I'm doing here? I'm at 3.5, and then I go 2 to the left. So here, I want to go in between here and go 1, 2. There's another point. And according to this, reading from this perspective, it says y is greater than or equal to. So I got a solid line. So very carefully through here, pull it solid line. Extend it far enough so you can see it. It doesn't matter if you go past off the graph as long as you're showing, because you may have to exaggerate. Now, one more time, for those of you who want to come back to me and say, hey, you know, why didn't I get points, or was my line, it looks like it's at 0.33 and I did this, you have to fight, you have to sit back and be tight on your graphing is what I'm saying. So if you want to, just to be clear and be safe, label the points that are on the line so that somebody can see where you really are, and be careful with how you're doing your work, okay? So I would tell my teacher, this is how we used to do it back in the day, is I would say, hey, you know, this right here is at 0, 2.5. So I would label 0, 2.5. Then I would tell somebody this one is at -2 and 3.5. So right here, -2, 3.5. Again, you know, I would have a pencil so I can have mine look way better. And then this one is at 2, 1.5. That way somebody can see the points. And then even if, you know, I'm in a rush, and I have, you know, 50, 60 papers to grade, and then I have my other group, I could at least give you credit because I'm seeing that you labeled your points, and I'll just put a check and keep it moving. All right. So now we're not done with the shading. So again, y is greater than, so I want all the values here above this line. And I would not shade over my points. I would have them below neatly. And then, all right, so now let's go to blue. Okay, for this one's going to work out a lot cleaner, right? So -4 is right here for my y-intercept. And my address, because this is a 1, it's just up 1, 1 to the right, up 1, 1 to the right. So from here, let's go up 1, 1 to the right. I'm also going to go back to the y-intercept, go down 1, 1 to the left. So I have this one, down 1, 1 to the left. And then I can go back here and go up 1, 1 to the right. So I just got multiple points here. And now this one is saying y is less than or equal to. So since I see that line, it's solid, extend it past so you can really see their intersection, and then we're going to talk about shading. Okay. And so for this one, again, you could label the points, and I would label them above the line right here, but I'm shading everything that is less than for my y. So I want to go this way. And so right here, see what I'm saying? Right here, I would tell somebody, again, I would also extend this green one. That should be green. This is the part or I'm noticing that they overlap right there in blue and green. Okay. Now, again, I told you guys in class, those of you that were paying attention and listening, you know, how do you know you're right? Well, you could choose a point inside of here, and you can check it to see if you're correct. So even though I shaded like crazy on this, I'm going to zoom in. I comfortably feel like this x-intercept is in there. So I'm going to check the point 6, 0. Okay, so I'm checking 6, 0 in that shaded area. So that means this is my x value, this is my y value, and I'm going to plug them into both of those equations, original equations, and see if I get true statements. So x is 6 minus y is 0. Is that greater than or equal to 4? Yes, it is. Loop. Now I'm going to check the bottom one. 2 times 6, 4 times 0. Is that greater than or equal to 10? Well, this is 12, and that's 0, which 12 is greater than, not equal to, but it's greater than 10. Don't let the equal to throw you off. So because that point satisfies both of those equations, I did shade the right area. Yeah, hopefully that makes sense. Okay. All right, so now let's go to the last one. Now in this one, again, my screenshot. So I'm going to go back to number 16, and that'll end this one. Hope these videos are helpful. All right, so for this one, number 16, this one's pretty interesting, but don't let it freak you out. So for this one, I'm just dividing by -1, which again, I'm going to switch the sign. So I get y greater than -x. For this one, let's divide by 2 everywhere to each term. So this becomes y less than 5/2 x, which that's 2.5, but we don't need that. Now again, 9 divided by 2, I already know that that's the same as 4.5. Okay? Do your division, top and bottom out, change to a decimal. All right, so let's do the top one. Now, again, I already know the address is down 1, 1 to the right, down 1, 1 to the right, but again, I have no b value back here. Not going to freak out. It's 0 at the origin. So we're going to plot 0, 0, and from here I'm going to start my address. So I'm going to go down 1, 1 to the right, down 1, 1 to the right. I can go back to the origin, which is my y-intercept, and go up 1, 1 to the left. All right, see that? Now again, when I read here, it says y is greater, and there's no line below this inequality, so this is a dashed line. And again, I go off, I'll put little dashes in between. Got it. And I'm going to read again from the y perspective. So y is greater. So I'm going to shade everything above this line very neatly and careful. And then I can't stress enough, label your points if you want to fight for your stuff, because when I grade this is a 1, -1. You know what I'm saying? Label them and make it clear, because I don't have time to be every single person look at this and look at this and look at this for me. Okay. All right. So now go into green, and for the bottom one I'm at 4.5, which is right here. Is that, honey? That is not green. Just joking. This is green. Just believe me, it is. 4.5. And then my address is, be really careful on this one. Again, down 5, 2 to the right. So again, from this 4.5, not down, I'm sorry, up 5 jumps, and then 2 to the right because of this, okay? Again, m is 5/2. We're going to go up 5, right 2. That's the address. Now, again, very carefully, I'm telling myself adding 1 would give me 5.5 is 1 jump. Adding 1 would give me 6.5. Adding 1. I hope this is making sense. Some people are looking at me crazy. Okay, but the problem is if I do 5 jumps, I'm going to jump off the page, right? So you don't have enough room. So you should be able to, being comfortable, go the other way. All right. So from here, let's go. I'm going to switch it up. Let's go down 5, and I'm going to just show you. I'm changing this to negative. I'm going down 5. And if I'm doing the opposite, I got to go to the left, which would be like I'm going left 2. That still will be a positive 5/2. So because I'm going to run off the page, we'll go back up to that 4.5. And now I'm subtracting because I want to go down 5. So I'm going to subtract, 1.0, 3.5, subtract 1.0, 2.5, subtract, okay? Those of you that know, I'm sorry, this is mundane, but for some people, so I can't hear anybody say anything about they didn't know what to do. Okay, so far that's 1 jump, 2 jumps, 3 jumps, 4 jumps. So let's do one more time. We'll end up at negative 0.5, okay, for 5 jumps. You see how I did that? Then I'm going to go 2 to the left. So for what was here, I'm going to end up, again, this is my 1. I'm going to erase this out the way real quick. I'm so tired. It's like almost 6:30. There. Okay. So again, negative 0.5. This is negative 1 right there. Negative 0.5 would be just right there. And I want to jump 2 to the left. So 1. I would end up right here. Put a big dot right there. And then we could also do this again. So if I take this and I go 5 down, this is just me. See? I would end up at, I'm adding those together, negative 5.5. So at negative 5.5, I'm just showing you, and then 2 to the left. So again, this is negative 5. Negative 5.5 is right here, and then I would go 2 to the left. But again, we were coming from this point. So I'm going to very carefully go down here to 5.5. Again, I'm right here. And then 1, 2. There's another dot right there. And again, I'm going back to this and saying y is less than. There's no line under here, so this is another dashed line. Be neat. Label the points. Get full credit. Know what you're doing, right? So again, I'm reading y is everything less than. So I want to shade everything this way. Okay, and where the blue and green overlap, that would be the answer, which in this case, you don't have to, okay? But I mean, I see my blue and green very neatly, but it is this area right here. Yeah. Okay, you can choose a point in there, and again, you can show that it satisfies both equations. So I could choose, you could choose 6, 0, 4, 0. You could even say, hey, 3, 4. It's in that shaded area, and then check. Alright, so this concludes this video here. I hope it makes sense. And that's all you have to do to show your graphing. And one more time, on recording, I'm going to say this very, very carefully. I could have put an absolute value inequality with a linear line. Because again, those are skills coming out of chapter 2. And because we didn't spend a whole lot of time on it, it's something you had to keep fresh. And then I want to hear those questions if you're like, hey, can you do some of these? That way it doesn't seem like it's not fair. All right. I'm being clear on that, because the other groups, they're getting a combination of whatever. They're getting 2 lines. They're getting absolute value inequality with a line. So if we don't understand transformations with an absolute value, come and see me, ask those questions so we can do 1 or 2 and jump into new material, and then let me present stuff. All right. But in this case, I am going to be fair. And again, it's 2 lines. All right. So that ends this video.